Empirical formula gives the simplest ratio of each atom of each element in a compound, whereas the molecular formula gives the actual number of each atom of each element. Empirical formula can be worked out from experimental data when you have the percentage composition of each element. For example, if we had a hydrocarbon that has 85.7% by mass of carbon and 14.3% hydrogen, we could work out the empirical formula as follows. Our figures by mass are percentages, so we can convert this to grams by saying 100 grams of our compound will contain 85.7 grams of carbon and 14.3 grams of hydrogen. We can then work out the number of moles using the triangle mass over Mr. Mole, covering N to get the formula for the number of moles equals to the mass divided by the molar mass. So the number of moles of carbon would be 7.14 and 14.3 for hydrogen. We need to change this to the simplest whole number ratio, so we divide through by the smallest value, that is 7.14. This gives us a whole number ratio of 1 mole of carbon to 2 moles of hydrogen. Our compound would therefore have the empirical formula of CH2. If we were then told our compound had a relative molecular mass of 56, we could work out the molecular formula. We would need to work out how many CH2 units give a relative mass of 56. One CH2 unit will have a relative mass of 14. So if we divide 56 by 14, we get 4. So our molecule is made up of 4 units of CH2. So our molecule formula is 4 times CH2, which gives C4H8. Displayed formula is when all the atoms and all the bonds are shown. For example, 2-methylbutane has this displayed formula. Its molecular formula would be C5H12. In this case, the empirical formula would also be C5H12, as you can't get any simpler. The structural formula for this compound would look like this, where the CH3 group is written like this, and then the carbon with the methyl branch is written like this, with the methyl group in brackets to indicate it is a branch off the main chain. Then the CH2 is written like this, and then the CH3 at the end is written like this. Let's look at a few more examples. Propan-2-ol has the displayed formula like this. In the structural formula for this compound, note how the OH group in position 2 is shown in brackets to show it is connected to carbon 2. The molecular formula will be C3H8O. The empirical formula will be the same. (2-methylpropanoic acid displayed formula looks like this, which translates to this structural formula. The molecular formula is represented as follows. In this case, the empirical formula will be different. It will be C2H4O. Skeletal formula is where carbon chains are represented by a zigzag line, and the carbon-to-hydrogen bond is not shown. For example, ethane is represented as just a single line. Propane is like this, with the ends of the line representing carbon atoms, and the middle carbon represented as a point in the kink of the line. 2-methylpentane would be represented in skeletal form like this. Note how the methyl branch is shown as a single line coming off the main chain. 2,2-dichloropropane-1-ol is shown like this. When atoms other than hydrogen are bonded to the carbon chain, then these are shown in full. Double bonds are shown as 2 parallel lines, so propene is shown like this. Cyclopentane is shown like this.